This is your chapter 5.6 notes. I do apologize, I have a little cold, so bear with me. This section is dealing with annuities and loan repayments. So I tell you here, annuity is a financial plan characterized by regular payments, meaning it's the same amount that comes out every month. Also think of it as not just a payment, but also like a deposit, like if it was a savings account. So I'll tell you down here to think of it as a savings account with the same amount being deposited each day, week, month, or year. Okay, but you could also think of it as a loan, and you make the same payment each month. That's what we're kind of more familiar with, unfortunately. Alright, so this first example I give you, this is the future value of an annuity. So meaning that if I'm going to put in our dollars every single time period, whether it be month, day, week, year, whatever, every single period for n periods into an annuity that pays some interest rate at the end of each period. Now, I will not be just the number that they quote you. Like I is not going to be 12% in this next problem. You have to usually do a little work to find I, unless you only contribute money each year, and in that case I is the percent they give you, but usually you have to do a little math to calculate I for this formula. You have to do a little math to calculate N as well. Okay, but R is a regular payment, I is the interest rate divided up by how many interest periods there are in a year, or compounding periods, and then N is the total number of payments, or the total number of deposits from beginning to end. So I'll just kind of walk you through an example so you know what's what in these formulas. So Harry's going to deposit $200 at the end of each month. So that's what R stands for. So in this formula, that 200 bucks is R. Alright, at the end of each month, into an account that pays 12% interest per year, but compounded monthly. Alright, 12 months in a year. Obviously. Hopefully that's not new to everybody. But because there's 12 months per year, we're going to take this 12% interest written as a decimal, and we're going to divide by 12 because that's what I represents. I is the interest rate at the end of each period. So since there's 12 months in a year, we're going to put 1% of this 12%. Right? 12% divided by 12 is 1%. So we're putting in 1% each month for however many years we have. Okay, so let's just throw it into the formula and see what happens. We end up with S equals R, which is 200, parentheses, times, up top we've got 1 plus 0.01 is what I ends up being. Sorry, this is I meant to put that out beside it. 1 plus 0.01 to the n power, all divided, or minus 1, all divided by 0.01. Alright. And n is however many periods we have go by. So how many months pass, basically. Alright, so this is our formula, okay, and that's all we're having to find initially, but then it says find the future value for every 4-month period. Okay, so this is what we're going to plug into our calculator, and then we're going to use our calculator to help us get the rest of this. Alright, so I've got it in my calculator, and I'm actually going to put that in here so I can talk about it just for a second. Alright, so notice here that I have the 200 times, alright, this is what I'm plugging into my calculator. The 200 times 1.01 to the X, because I don't have an N button, minus 1. Alright, close that parentheses. That's all the numerator divided by 0.01. Okay, now notice there's a parentheses around the whole entire outside. Alright, if you wanted to, you could put a parentheses around the whole thing, but since there's just a single thing down there in the denominator, as long as I have the numerator where that minus sign is grouped in a parentheses, I don't need it. But again, if you're ever in doubt, do I need this? You know, remember, they're important. So if you're ever in doubt, put a parentheses around it. And now this looks just like this. Alright, the parentheses not showing up there in the in the simplified version of the formula because it's in the numerator. Alright, but I had to put it in here for my calculator. But this outer parentheses group here is not necessarily needed. Alright, put it in there if it makes you feel comfortable with it or whatever, to make it look like this formula. But it's not necessary. Okay, now we're going to use this and we're going to come up with the table. So I'm going to scroll down here, show you the table that I've got set up here, and we're going to use this table to fill in and answer the question. So it told us, if you look back at the question, it said find the future value for every 4-month period up to 36 months. So that means in each one of these periods we're going to look at 4 months, 8 months, and all the way down to 32 months. Alright, so I've got that filled in. Now I just want to find the value, and that's where my calculator is going to help me. So I've got that stored in there. Go to your table set. Alright, tell it to start at 4 months, or 4. That's start value for X, and then tell it the gap between, tell that to also be 4. Alright, and then hit second graph, go to your table. So there's our numbers. Okay, so 4, and then I scroll down, I can get the 32nd one. So I'm going to fill in the table real quick. Alright, so I've taken these values from my calculator and just plugged them in over here. Okay, so let's think about it back again, what this is asking, what we've actually found here. We're putting $200 in at the end of every month into an account that pays this much per year, and we're trying to figure out how much we've earned after 36 months. So putting in $200 a month after 3 years, basically, or excuse me, I'm sorry, going into the 36 month. I stopped at 32, so 36. Alright, 86, 15, 40. So that's how much money we've made. Putting in that $200 a month for 3 years. Okay, it's built up. Now if you think about it, $200 a month for 3 years, that's 200 times 36 payments. That's $720, and you see we built up more than that, substantially more than that, because of the interest that's been established on this account. Okay, so that's what happens with annuity. When you put in something into an account that pays interest over time, it builds up faster than just stashing it on your couch or something. Alright, so that's what's going on here, just to show you how the formula works. Now usually the questions will ask how much is in there after this certain month or this certain amount of years, rather than to make a table of everything like this first question. But we can be asked to make tables, and we are often asked to do that. Alright, present value. This is something that you see like in the commercials for investment companies. They'll say, how much do you need, once you retire, how much do you need to have, like this nest egg, to make it through, to last until you pass. So that's what a present value is, basically how it works. Now if you look at the formula for present value versus a regular annuity, if you can read through my scribbles, notice this is 1 plus I to the positive n minus 1 over I, and there's an R out in front. And here we have 1 minus 1 plus I to the negative n over I. So what's happened here is these two have switched places, the 1 and the 1 plus the I to the n. Okay, that's changed to a minus, and that's changed to a minus. Okay, that's the big things that you see there. They've switched places there, and then that's become a negative n. Okay, when we're doing present value, we're kind of working backwards on this thing. Alright, so but everything still stays the same as it was. R is the amount that is now going to be taken out of this fund every month. instead of deposit in, it's going to be coming out every month. I is the interest rate that it's earned, and N is the number of periods that you're going to earn interest. Alright, so suppose a retiring couple wants to establish an annuity, so they want to build this big fund that they're going to take an amount from. That's going to give them $2,000. That's going to be our R. At the end of each month for 20 years. Okay, so that's not all the N is, right? That's part of it, but it's each month for 20 years. So 20 years times 12 months is 240 months. So that's what N is, right? N is the number of periods. So we need it come out every month. So that's 240 periods. The annuity earns 6% compounded monthly. So again, we need to take that 0.06 and divide it by 12. Alright, that's 0.005. Sorry, I had to cough. That's going to be our I. And we want to know how much the couple must put into the account to establish the annuity, get things started. This is what they have to build up to be able to take this $2,000 at the end of each month. Okay, so we've got R, we've got I, we've got N, so we're ready to go. So A equals R is 2,000, parentheses 1 minus parentheses the second set of parentheses, 1 plus I is 0.005, right, raised to the negative N, which is 240. All that over I again, right, which is 0.005. Alright, and that's what we're multiplying this 2,000 by. Okay, now I'm going to simplify it again just like I did before. So 2,000 times parentheses 1 minus, alright, 1 plus 0.005 is just 1.005 to the negative 240 power all over 0.005. Alright, then throw this into your calculator once you're ready to do it. 2,000 parentheses, alright, this is in the numerator. Okay, so we're going to need a parentheses here. So 1 minus 1.005 to the negative, use this for negative, not the minus sign, or your calculator will give you an error. Negative 240 power. Alright, all that's the numerator, so close that parentheses, and then that's being divided by 0.005. Alright, so this is how much money Grandma and Grandpa have to have to be able to do this. So $279,161, and make sure you get those pennies right, because that's the important stuff. 54 cents. Alright, now think about that. They have to, so think of a retirement couple. They're in their 60s, mid 60s, upper 60s. 20 years, they're basically, this is what they're going to have to live on for the rest of their life, and they're just getting $2,000 a month plus, you know, whatever, Social Security or whatever. But that's what they've had to build up over the course of their working careers to put away to be able to pull this off, to not have to work to make this $2,000 a month the rest of their life. So you know, whatever you're doing, whatever career you're in, make sure that you are putting some money away, so you don't face your mid 60s with a big fat zero that you've stashed away, because it takes a big chunk of money to be able to sustain those last so many years. Alright, so that's a present value form. This is what I need to establish to be able to take away this amount of money every month for so many years. Now, what's another thing that's like that? A mortgage. If you think about the way a mortgage works, you loan an amount of money, and then you pay on that amount that you've borrowed every month for so long until that thing goes away. Well, that's kind of the reverse of the way this thing is, right? This you build up and you take that money for yourself to live off of the last so many years. Well, that's basically what a mortgage is, but instead of you build it up, you are loan that amount at the beginning, and then you pay it back over time until that balance is zero. Alright, so we're still going to use that present value formula to do a mortgage. Now, a couple wants to make a purchase of a home, has $30,000 for a down payment, and wants to make monthly payments of this amount. Right, in that formula, R is that monthly payment. Okay, so that's R. Oops, sorry, that's not R. This is R. Interest rate is for a 25-year mortgage is 6% per year on the unpaid balance. What's the price of the home that they can buy? Okay, 6% per year. You're making monthly payments. Okay, so we're grouping these two things together. You underline both of them twice, so we'll know they're grouped together. These two things are giving us the I. So 0.06 divided by 12 again, just like we did last time. It's 0.005. That's our I. Alright, we want to know what's the price of the house that they can buy. Alright, well, the price of the house they can buy is the the present value, that formula we were talking about in the previous slide. This, alright, plus their down payment. So they have a $30,000 down payment, so we know that's going to be part of it. Alright, and then, so there's our $30,000 down payment, and then this is our formula to get the present value. Ooh, I got extra parentheses in there, so ignore that. And then I'm going to simplify that. So this is the $2,200 payment. 1 minus 1 plus 0.005 again. It's just 1.005. That's a negative 300 power. Now, I want to explain where everything in this formula is coming from, so you know why I set it up this way. Oops, I forgot the 30,000. 30,000 plus. So up here, the 0.005, that's I in the formula. So there's the I again. Alright, the 2,200, that's R. We said that was R to begin with. The negative 300, where's that coming from? It's 25 years monthly payments. So 12 times 25, do the math, and you get 300. So remember, that's what N represents, is how many payments you make. Alright, so, or how many periods you have. Alright, so I'm going to go to my calculator, plug all this in, and get an approximation. Alright, so this part right here, the 2,200 times 1 minus 1.005 to the negative 300 divided by 0.005, all of this, second part, is equal to 341,455. Alright, again, plus some change. Don't forget the change. 10 cents here. Alright, but we're going to add to that the $30,000 down payment. Alright, don't forget your down payment, because that's a big thing that people leave off. They're doing all this stuff to fill in this formula, and they forget that they put some money down on it. Alright, so that means that they can afford a $371,455 house. 10 cents. Don't forget the 10 cents. So this is how much they can afford on a house. That should buy a pretty nice house. Pretty good view. Alright, so on a problem like this, when you see that down payment, don't forget to add that in at the end along with the present value part. Alright, so the last part of this, amortization. So basically, what usually happens if you get a loan from a bank, if it's for a big amount like a car loan or a your college loans, or a mortgage specifically, they usually amortize that loan meaning they make the payments equal at the end of each month. So all of them are the same size. So usually that's what's going on. So this is how this formula works. So if you have a debt of $8, so this is your loan balance or your total loan amount, interest rate of this amount per period, right, for this many periods, this how many payments you're going to use to pay off that loan at the end of each period. This is how much you're going to pay. Alright, so first of all, we want to know what's their equal monthly payments. That's part A. Alright, so we need the formula. R, which is what we're looking for here, is equal to A is the unpaid balance. So 230,000 is the amount of the home, but they're putting down a $50,000 down payment. So that's 180,000 is the unpaid balance. So their loan's going to be for 180,000. Alright, and then we need the I figured that up here, 0.09 per year. Alright, 12 months in a year, so it's a monthly payment. Sorry, that's where it's coming from. Monthly, so that's where the 12's coming from. So that's why I is 0.0075. So 0.0075 up top. On the bottom, we got 1 minus. Alright, and again, 1 plus I is 1 plus 0.0075, so I'm just going to go ahead and write 1.0075. Same reason we've been doing that. Alright, and then close parentheses, once again, N is going to be 25 times 12, so negative 300. Alright, and there's our formula that's going to give us R. Alright, I'm going to approximate it. I'm going to throw all this into my calculator, and that'll give me the amount. Alright, now notice something a little bit different this time. When I start my parentheses, I have this is the numerator, and then divide by, there's the 1 minus this. I've got that in the parentheses because we've got subtraction in the denominator. Okay, you got to have a parentheses to indicate that. So this outer parentheses indicates the multiplication. That's these parentheses. Okay, but this inner parentheses pair is because of the fact we have subtraction down the denominator. Don't forget that. It'll screw your numbers up if you leave it off. Alright, so hit enter, and that'll give us our monthly payment of $1510.55. Alright, now part B. If you're getting ready to buy a house, you might not want to watch part B and C. Alright, but part B says, what's the total amount they're going to pay before they own the house outright? Meaning, we're going to pay this $1,550 or $1,510 payment every month for 300 months. Oops, 300 months. Alright, how much did we end up paying? So $1,510.55 times 300 months of paying that, $453,165. Alright, now that's what you paid paying back the house, but you also paid how much down? $50,000 down. Oh, yeah, add it together, Dave, which is $503,165. That's how much you totally paid at the end. Alright, so how much of that was interest? That's what part C asks. Well, interest is what you actually paid minus what you would have paid if you would have paid cash. So $230,000 is what you would have paid if you could have paid cash. Alright, put it in the calculator, drum roll, $273,000 in interest. So yes, you pay more in interest than you do for the price of the house. That's the way mortgages run. They're evil. That's why I told you to look away if you're about to buy a house. Okay, so it's a little bit better now. I mean, interest rates are not. This one was what, 9%? They're like half of that right now, but still, it's usually close to double the price you end up paying if you had to borrow anywhere close to the full amount of the house. Alright, so that's that section. 5.6, only one more section to go in Chapter 5.